Morning everybody. Today we're going to start looking at sectors and segments. Yesterday we looked at arc length. So just a little reminder quickly what a sector is. A sector is a part of the circle, so enclosed by two radiuses and the circumference. So if you think about it, it's like a slice of pizza, I suppose. It's probably one of the best ways to describe it. A segment is just part of a circle, which could be, so for instance, if you think about it, I'll draw a picture, it's easier, isn't it? So if I take a chord within a circle, a chord is just some line that attaches to the circumference in two places. This bit in here would be known as a segment. I suppose this bit would be too, but we generally think about the minor segment there. Just an interesting fact about chords. There's one very special chord that you will know, and that chord is the one that goes through the centre of the circle, and then it becomes something called the diameter. And when it goes through the centre, then this wouldn't be a segment anymore, it would be then a sector, because it would be all this bit round here through the centre of the circle. So that would be a segment, and a sector is something like this. So basically sectors involve the centre of the circle, segments don't. Okay, so we're going to try and work out the area of these two things today using radians. And so we're going to start by thinking about thinking about sectors. And you guys know how to work out the area of a sector from GCSE. You would always say you do the angle divided by 360 times pi r squared. So you can, like yesterday, think about this in terms of, okay, well, it's theta radians over 2 pi, and then you can see what cancels down. Or what I'd like you guys to do, actually, instead of doing it that way, do something slightly more interesting. Can you try and manipulate this equation so you can times theta degrees by some bits of this to convert it into radians and see what you have left? So just pause the video and see if you can drag out the things you need to convert from degrees to radians. So hopefully what you've done is you've said there's 180 degrees in here, there's two lots of 180 degrees, so I'm going to take 180 out of that to make pi 180 times r squared. Just check that that actually works still. If I remember how many times fractions together, that goes back there to make it 360. This all still works fine. Times in degrees by pi over 180 converts it into radians. But before I do that, I'm just going to get the half out of the way to make this really obvious. So I've got theta degrees times pi over 180 times r squared. And I can see that this bit here, if I take theta degrees, I times it by pi over 180, this converts it into the angle in radians. In other words, the area of a sector, when I'm thinking about radians, is half times r squared times theta c. And just a quick point in general, with this and the arc length formula, the theta seems to go at the end. I'm not really sure why, if there's a particularly nice reason. Aesthetically, I suppose it looks nice because we've got something interesting here and then something interesting in the middle, and then this one's bigger. I don't know what it is, but that's generally how it's written. Not normally with the C written on it, but that's just for clarity purposes for this example. Okay, so that's the formula. I need to double check whether it's in your formula sheet or not. I can't remember if it's not, if it is or it isn't. In your textbook, you've got a formula to work out segments as well. I'm not going to give you a formula as such for that because I think it's just a bit daft, and you should never try and remember that formula. You should remember how to do it as opposed to remember the formula. We're going to do an example now where we see how it works. Okay, so let's do an example. So this is our example. We want to find the area of this segment here. So if I just put some extra bits on here, let's call that O, let's call that A, let's call that B. We've got the triangle OAB in here. We've got the sector, which goes OA to B around here, and then we've also got the segment between A and B and the circumference. So there's three different shapes here. There's a triangle, there's a sector, and there's a segment. So have a quick think. How could we use those three things, or write down, I suppose, finish this off for me. So area of segment is equal to what other two areas, the difference of two other areas of the shapes you can see. So hopefully you've said area of segment is going to be the area of the sector, so all of that. Take away the area of triangle, area of AOB, or OAB, whichever way you want to write it. Okay, so what I'd like you guys to do is pause the video, and I'd like you to work out what these two different areas are. I'd like you to try and see if you can do this going down the page. So keep the area of the sector in this bit, the area of OAB in this bit. If you can't remember how to do this, have a quick think about your GCSE knowledge, thinking about finding the area of a triangle which isn't where you don't have the perpendicular height. Pause the video, have a go at that, and see if you can get to the end. You should get 15.4 centimetres squared. Okay, so hopefully you've written down the formulas first before you substitute anything in. Half r squared theta is the area of the sector. Half AB sine theta is the area of this triangle here. You don't have to do any jiggery-pokery with this formula. You just need to make sure that your calculator is set in radians, not degrees. If you haven't done that before, where's my calculator? Here it is. Oops, I've been doing something else which is slightly interesting. So I think if you go, setup probably. Yeah, so go shift this button, and then go 2 for angle unit, and then 2 for radians. Okay, I've done mine as well now. So if we substitute in what we know, we've got half lots of, the radius is 5 times 2 pi over 3. Take away half times, and it's 5 squared, again because A and B, here's A, here's B, or interchangeably. Times sine, so you used to write this as sine C, so this is the side C if that's A and B, so this would be the angle C. It's fine to write it as sine theta, it's up to you how you write this to a certain degree. Sine 2 pi over 3. Now this is where it's quite useful to know some of your angle facts. So on this side we've got half of 25, that's times 2 there, so we've got 50 pi over 6. If you work that out. On this side we've got 5 squared, those 2's will cancel. No, they won't cancel because that's within the function. So sine 2 pi over 3. If you think about what your sine curve looks like. It is necessary to make those noises, by the way. So thinking about what sine 2 pi over 3 is, sine 2 pi over 3, if you convert that back into degrees, is 120 degrees. So that would be about here, that's 90. So it's the same as what sine of 60 degrees would be. If there's a sine of 60 degrees, well, that's root 3 over 2. So this is minus a half times 25 times root 3 over 2, which equals 50 pi over 6. Take away 25 root 3 over 4. Now I think it's a good idea to keep doing these stages down to here as a form of practice, because it's good for you guys to make sure that you can accurately make things simpler, because sometimes in the exam, instead of saying giving your answer in terms of, or instead of saying what's the answer, they might say give your answer in terms of a lots of pi minus b lots of root 3 or something. So it's good to actually practice this regularly. At this stage, because it hasn't asked me to do so, I'm going to stick this into my calculator and hopefully I get the right answer. And I get 15.354, which rounds to 15.4 centimetres squared. So this is probably one of the most common sorts of questions they ask to do with areas of sectors, because they can make this slightly harder by bringing the segment ideas in. So what I'd like you guys to do today is to practice a few more of these. Tomorrow we'll do a bit of a recap on solving equations using radians. So basically it's nothing new, because it's all the stuff which you'd have done in your trigonometry from the year 1 book, but we'll just be revisiting it, but now we're using radians. And on Thursday we'll be looking at small angle approximations, and we'll be doing the test on Monday. I know my class, you guys have done some of this radian stuff before, so I would suggest that you keep going over some of it and making sure that you're really good at it. Miss Kelly's class, you're probably not listening because I've given you a past paper to do, and whoever the other class is, and Mr. French and Mr. Green's class, as far as I know, you guys haven't started this, so this should all be new to you. Okay, Miss Kelly's class, if you are listening, there's no reason for you to do the topic test on Monday because you've already done the topic test. Okay, so questions for today. Okay, so these questions for today: exercise 5D, question 1, C, E, F, question 3, and then question 9, 12 and 16. Okay, thanks very much, and I'll speak to you guys again tomorrow. Bye bye.